Welcome YouTube. I'm going to show you how to convert my Briggs & Stratton 5550-8550 generator. It has a 10 horsepower Briggs & Stratton engine on it. I'm going to convert this over to propane using a spud-in method, and that is a permanent modification to the carburetor, so there's no going back to running on gasoline without replacing the carburetor. So I've already converted it. I started up just a second ago. I'm going to take it apart, show you how to take it apart and what it is you need to do to this to convert it. It's a pretty simple process actually. So here, hopefully the lighting's good enough to see this. It's currently about 14 degrees outside. So first step, remove the air box. Airbox and filter removed. Next, you've got two 7/16 nuts right here to remove this cover. And remove those. I've already removed the other one. This comes off and you can slide it out of the way. Oh, also, just so you know, I've already removed the gas tank, drained the fuel, and I removed another little shroud down here that I don't think I'm going to put back on. Okay, remove your gasket. Set it off to the side, and then looks like a 5/32 socket. We'll remove the carburetor studs. Okay. And then the carburetor is free. This fuel line almost free. Okay, so the carburetor's off. As you can see here, there's the regular gasoline fuel inlet. This is the choke butterfly. Over here you've got the throttle butterfly. Okay. And this is what the carburetor looks like after I've modified it. So in order to do that, you have your float cover that has two screws. Remove those screws. Your float comes off, or your bowl comes off. Underneath that, you'll have this little float mechanism. It just pops right out. Not going to need that. And there's your gasket. You're not going to need that. And back to the carburetor. There's a couple of holes in there that I just put in some RTV sealant. Through the middle of this used to be the gas mixing tube that would go down into the float. I used needle nose pliers and it just pulls right out. And then what I did is I came in here, right here, and I drilled. I used a drill bit size R, and drilled all the way through there, all the way into the bore of the carburetor. Okay. And then I tapped it out with 1/8 inch NPT. Okay. I'll go ahead and remove this so you can see what it looks like. Okay, and this is my spud in that I made. This is a 1/8 inch brass nipple, and this is a 6mm copper tube. You could use 1/4 inch too. I just had some 6mm sitting around. I drilled out the center of that nipple. I cut a piece of copper tubing. Notice the approximately 45-degree cut. You'll want the open side going towards the engine, As the air comes in, it creates a vacuum and sucks the propane through there. To that nipple, an 1/8 inch elbow, an 1/8 inch needle valve, and then a 1/8 inch to 1/4 inch brass nipple. So I put that assembly all together. Also, just going back here, I don't know if you can see that or not, but I soldered this tube into that nipple. Just used a propane torch and some regular solder, heated it up, put it in there, twisted the nipple in to where I got it the flare to the proper side of the carburetor. So that is the entire modification necessary. And so let me set down the camera, take a quick break. I'm going to rethread this, put some new tape on it, and reassemble it. And I'm going to put it all back together. One more quick thing. Here is this little intake manifold thing. It's an adapter that goes from the carburetor to the engine. You'll notice I drilled and tapped 1/8 inch nipple into that. And so that runs the vacuum. I'll go ahead and give you a walk through the regulator. So this hose, the vacuum hose, comes over here. Into the vacuum port on the regulator. This is high pressure in. And over here is the fuel outlet. This is a Model T60 regulator. It's rated for up to 60 horsepower, commonly used on small tractors and forklifts. This is quite a bit different than the other ones you typically see for generators. The ones you typically see for generators use a regulator from the tank, which will drop the pressure down to 12 psi or so, and then it's a smaller regulator that goes into the engine. This is just one regulator, does it all. If you check out my other videos, you'll notice I have the exact same regulator on my propane lawnmower. That's a 17 horsepower riding lawn tractor, and I've used it all year and it works great. Here is a primer button, and so you'll push that to prime to start. This regulator is also set up. These black caps are to hook up coolant lines, and so if you were running liquid into this, you're going to definitely need coolant lines running in here, which I don't have on my generator, to keep that warm and keep it from freezing up. I'm pulling out of the gas side of a propane bottle currently, so I don't really have the vapor issue or the freeze up issue. I plan to mount my generator to the bed of my flatbed truck, which has a 103-gallon propane tank on it. And if you check out my YouTube videos later, I'm going to show you the conversion of my Ford F450 using some propane kits that I recently purchased. So that's the regulator setup. That's the brains to the system. They make kits that you buy that are just a spacer that you put in there. You don't have to modify your carburetor. They're easier to install for someone that doesn't have tools, not really that handy. They're a little bit more expensive. This regulator that I bought, I got off of some website, maybe propanecarburetors.com, something along those lines, and I think it was about $70. So I went ahead and bought that because I'm using that same one on my lawnmower, like I said, and I've got another one that I'm planning on converting a motorcycle. So I just wanted to have interchangeable parts. So I'm going to take a quick break of this video, reassemble the carburetor, put it all back together, and then I'm going to show you how to tune it using the needle valve in order to get this thing to start up. And the only thing I'm not going to be able to do in this video right now is to adjust the RPM. A generator like this needs to run at 3600 RPMs, and that will produce the correct 60 Hertz cycle for the AC power. If you're not producing 60 Hertz, you can damage electronics. Generators do produce inherently dirty power that can damage sensitive electronics. For example, if you have a bunch of electronics hooked up and you have something else that kicks on and it creates a draw, the RPMs are going to temporarily drop on the generator, and then they'll probably recover to slightly above the 3600 RPM, so you'll get these temporary spikes. So anyway, I don't have a tack to do that on this video, but that is something that I'll have to do. Alright, so here's another quick view of this carburetor, maybe in a little bit better light so you can see it all hooked up. Once again, after I removed the bowl, and I pulled the original tube out of there with needle nose pliers, drilled it out, drill bit size R, used a 1/8 inch NPT tap, and drove it down through the bottom of the carburetor. 1/8 inch nipple is right there. Inside that nipple, so I can get the light to show up in there, you can sort of see that tube sticking up in there at a 45-degree angle, going on the engine side. You don't necessarily have to have the taper or the angle cut on that, but it will work better if you do have it. Some of the regular spud ends do not have that. And then an 1/8 inch elbow, 1/8 inch needle valve, an 1/8 inch NPT to 1/4 inch nipple, and so that's where I hook up the fuel. Get another close up in there. You'll notice I've done no other modifications to the carburetor. It's from the choke side, maybe we can see a little better in there. Okay. And then, as I showed you earlier, the only other modification, there was that plastic spacer that went between the carburetor and the engine. And I drilled a hole in the side of that and installed a 1/8 inch NPT to 1/8 inch nipple, and that runs my vacuum line. That regulator that I'm using has a vacuum safety. There's cheaper ones that don't have the safety. And the vacuum safety, when the engine quits running and there's no suction on that vacuum port, it'll shut off that regulator and shut off the flow of the propane. That regulator is about $10 more than the ones without the safety. In my opinion, the $10 is worth it. It doesn't take a whole lot of propane to waste, not to mention the danger of it. If your generator was to stop running and your propane just continued to flow, you could empty a tank and not know it, and then you would have a potential fire risk as well. So anyway, that's the spud end, the homemade spud end. They do make the spud end little things that have a similar valve on it, and I think those run about $30. This probably cost about $12 at the hardware store, buying all these brass components. And then I just used a piece of 1/8 inch copper tubing, or not 1/8 inch, 6mm copper tubing. See if I can find it over here on my workbench. Here it is. That's what I used. I had to drill out the nipple with a drill bit that fit that. I think it was drill bit size B. You could use another standard size and it would probably work just fine. And then after I drilled it out and I tested the tube would fit through that nipple, I went in with a step drill bit and I made basically a flare on the outside of it, and that was so the solder could suck into that joint and get a good seal. I did it without the flare and I couldn't get the solder to suck down in there very well, so I put a little flare to allow space for the solder to sit. So that was pretty much about all I did. To solder it, just used a propane torch head, no big deal, and some regular solder. So I'm going to go back and install it, and then I'm going to show you a startup on the generator. Welcome back. There's the carburetor mounted. You can see the black spacer, which is the intake manifold. You can see the nipple that I've installed there. You can see the carburetor installed. Once again, vacuum line goes over to this regulator. The fuel line down there is hooked up to the needle valve, goes to the regulator, and then hose from propane tank into regulator. And once again, this regulator does not require a primary reducer. So I'm going to start this up and demonstrate it running. And once again, as I stated earlier, the only thing I won't be able to do in this video is tune it to 3600 RPMs, which is very essential that I do that. And I'll do that as soon as I get a tachometer, but it's pretty easy to do. There's a little set screw that you adjust the RPMs with. Anyway, so I'm going to set down these lights, turn my propane on. I'll hit the primer button and you can hear it. You hear that? So that's the prime propane. Power switch is on. I just turned the propane tank off and it starved it of fuel, and I shut it off there. So there you have it. A few things I have remaining to do is reinstall the air box. This regulator, I need to cut this plate right here that I used for a mount. I'm going to weld it to the generator itself, or to the frame. I don't think I'm going to reinstall the gas tank. I'll probably build a new plate that goes up here to protect it from rain. I think I have some aluminum sheet metal that I'll lay on top of that and drill some holes. But that's pretty much it. Nothing special. The spud in is a very easy modification. I would say probably the modification to the carburetor, as far as taking the carburetor apart, I cleaned it with some cleaner. I drilled the hole, I tapped it out. That process probably took about 10 minutes. It was pretty easy to do. And then I created that spud in with the copper tubing and soldered it into the fitting and got it all lined up. That probably took another, I don't know, less than 10 minutes. So that's pretty much about it. Let me think if there's anything else I want to tell you about this. The tank, running from that tank is a high pressure propane hose. This one is a Parker brand hose. It's rated 350 psi. This hose is made for propane. I use these hoses on several of my other kits. I bought about a dozen of them at a time. I have my Camry that runs on propane. If you check my videos, I have a heater that I made last week on propane, and the generator now runs on propane. I have an F450 I'm about to convert with a sequential injection kit. I have a 1999 Dodge Ram 1500 5.9 liter. I'm going to convert it. A Toyota Yaris with 1.8 liter, I believe. It's going to be converted. I have a Honda VTX 1300 that I plan to convert to propane. I also have a Ford Ranger with a 347 stroker. It's built an engine I built several years ago. I used to have nitrous on it. Currently it has two Edelbrock 600s on it. I'm going to convert that to propane. And then once I get those done, then pretty much my entire fleet is going to be running on propane. And I'm not doing all this to be green. I'm doing it because propane is a much, much cheaper fuel source for me. I buy it in bulk, I have a 3,000 gallon tank at home. and I get an amazing deal on propane where it costs me about a third the price of gasoline right now. So that could always change later, but until then, I'm going to continue on with converting everything to propane. If you have any questions, post away. Subscribe to my videos so you can catch the other ones coming out probably in the next week or so. I'm going to be doing a conversion for my Honda VTX. I'll probably also be doing a conversion on my Ford Ranger. Those will probably be the next two that I do. And then my two trucks, which will be a little more involved by removing the intake manifold and doing all the modifications for those. But anyway, long story short, my generator, 5550, 8550, Briggs & Stratton. This is a very common generator. There's a bunch of them out there. I see them for sale on Craigslist all the time, used for $300 to $400. 10 horsepower Briggs overhead valve engine, running on propane. The only other thing I'm going to comment about this is I'm going to need to pull the spark plug and check the spark plug, and I may need to swap out the spark plug for a colder spark plug. Propane's going to run a little bit hotter. Propane